Okay, this video is of the notes from 227. We are in the Polynomials foldable, and we are on the last set of notes for the whole quarter, actually. So we already did solve graphically, solve algebraically. We are on sketching. So this y-intercept part should already be filled out. We should be over here in this last problem, and we are going to sketch it. All right, so the first thing you might notice is that it doesn't have as many prompts as we've seen before. So usually it says like, what's the degree, and then even or odd, and then leading coefficient, positive or negative. We're going to slowly take those things away. It doesn't mean you don't need them anymore. It just means we're going to remove those scaffolds. So we are going to do end behavior first, because we are going to need it. So we're going to look at the degree of each factor. So this is a factor because it has an x in it. The degree of this is 1. The degree of this one is 2 because it's a double root. And then the degree of this last one is also 2 because the highest exponent in this is a 2. We don't care about this 5x right here. It doesn't actually matter. So that means my total degree is 5. So if I look at the back of my foldable, I know my degree is 5, which is an odd number, and it's positive. The 5 itself is not positive, but in my equation, there is no negative sign in the front. So that means it has to be positive. So my end behaviors are down, up. So I'm just going to note that here so that when I get to the actual sketching part, my end behaviors are ready to go. All right, so I've got end behaviors. My next step is going to be to get the y-intercept. So everywhere I see an x, I'm going to sub in a 0. And I'm going to put that in my calculator. And you're going to end up with 0. All right, so I know what my ends look like, and I know I'm going to be crossing the y-axis at 0. So now I need to get my zeros. And just to remind you, your zeros are the same thing as your x-intercepts. So if this vocabulary is throwing you off, we're still going to just calculate this in the way that we calculate the x-intercepts. So if you recall, we take each factor and set it equal to 0. So the first factor is x, set it equal to 0. Well, that's already solved. So that's one of our roots, or x-intercepts, or zeros. And then I'm going to take x minus 2 and set it equal to 0. This gives me a root of 2. But remember, it's a double root, so I'm going to write it twice, just to keep track of everything. So here's 1, here's 2, here's 3. But remember, I'm supposed to have 5. So this is the part that is kind of new. If you notice, this last factor I have is 2x squared plus 5x minus 4. That's a quadratic. And obviously it can't be factored because it would have already been factored out. So the only way that we know how to do this without a graphing calculator, you are the graphing calculator, is to put it in quadratic formula. So I'm going to back up a little bit down here because I'm kind of running out of space. So I'm going to draw an arrow. We're going to take that equation, 2x squared plus 5x minus 4 equals 0. So we're setting it equal to 0, just like we did the other ones. So I'm getting that from the original problem. So the only way that we know how to solve this quadratic, this type, is to do quadratic formula. So my a is 2, my b is 5, my c is negative 4. I'm going to put that into the quadratic formula. If I am going too fast, please feel free to pause the video and catch up with what I'm writing. I'm going to put this in the quadratic formula. It should be on the back of your bookmark. Okay, so that's now in the formula. When I go to simplify this, the opposite of 5 is negative 5. All of this is over 2 times 2 is 4. There's a plus minus sign. When I put this in the calculator without that radical sign on it, I get I think I get 57. Okay, so typically at this point, we would try to simplify it using a radical, but we're not going to do that because I need to know what the decimal equivalent is. And the reason I want to know the decimal equivalent is because I'm trying to put it on the x-axis. I don't know what these numbers look like. I can't even estimate kind of where they would be. So what I'm going to do is split them into their two pieces. So the positive, that's the positive, between the -5 and the square root of 57. And then I'm going to do one where I'm subtracting it. Okay, and I'm going to put this in the calculator. Please listen very carefully how you're putting this in the calculator. The TI-30 calculator does order of operations. So when you put it in, you want to be very careful about what you're telling it to do. So I'm going to recommend when we put this in the calculator that you put in the numerator first, press equal, and then divide by your denominator. So I'll show you what that looks like. -5 plus, and remember to do square root, we do second and the x squared key. And I'm going to put in the 57. You don't even need to close the parenthesis at this point. I'm just going to press equal. But then I'm going to divide by 4. So notice I did that in two separate steps. We're going to be rounding to the hundredths. The hundredth is 2 after the decimal. So not just two numbers, 2 after the decimal. So in order to determine if I round up, I look at the thousands place. And since this is a 7, I'm going to round this up to a 4. So remember the place value to the right of it. If it's 5 or above, give that number a shove. Okay, so I'm going to do the exact same thing again, but I'm going to do it with the subtraction sign. So -5 minus the square root of 57, press the equal, and then I'm going to divide by 4. All right, so again, I'm rounding to the hundredths. So I'm looking at the hundredths place. It's a 3, but the number next to it is 5 or above. So this is going to get shoved up to a 4. All right. So really, we haven't done anything new, except we actually made it a little easier to get the quadratic formula answers from the quadratic formula, because now they're decimals. All right, so now we actually have all 5. We've got our 0, our 2 2's, and then we've got our 2 x-intercepts down here. So now we got to put it on the graph. So I'm going to put in my 0. I'm going to label it. I'm going to say 2 is approximately over here. I like to put that notation under there just to remind myself that it's a double root for when I go to connect it. And then I've got -3.14. That's going to be all the way over here. All right, and then I still have to place my 0.64. That's going to be not halfway between 0 and 2, but a little bit less than that. Okay. So 0 is also my y-intercept, so I don't have to put something separate on my y-axis. Now I'm going to connect all of my points together. My end behaviors are down, up. We found that earlier. So I'm going to start down here and up here. So I kind of put that little arrows there to remind myself the direction. So the end behaviors are where it's going to continue to point. That doesn't mean that's the direction my pencil goes. So I'm going to go through 3.14. It's a regular x-intercept. I'm going to come back down through 0, regular x-intercept. Come back up through 0.64. And then I'm going to hit 2, and it's going to be a double root. So when I hit it, instead of crossing, it's going to bounce back up, and that's why this end behavior is facing up. So notice I only crossed at the x-intercepts. Notice that I have a very nice rounded hills and valleys here. Nothing's pointy. My double root is very clear. My end behaviors are clear. They have arrows on the end. And that is going to be how you become Desmos. You are the graphing calculator.